Now, in this lecture, we'll find out the area of a square. In the drawing, we have triangle ABC, a right triangle, triangle ABC. Inside this right triangle, we have square DEFG. In addition, you know that side AB of the right triangle ABC equals to 5 units in its length. Side BC equals to 12 units in its length. This is angle ABC, that is a right angle. Our mission is to find out the area of this square DEFG. Okay, so first of all, we find out the length of the hypotenuse AC of the right angle ABC by implementing the Pythagoras theorem on this right triangle, triangle ABC. So, note that according to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Here by PT is the abbreviation for Pythagoras theorem. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC squared. And it must be equal to AB squared plus BC squared. Repeat again. According to the Pythagoras theorem, in the right triangle ABC, AC squared equals to AB squared plus BC squared. So AC squared, this is the square of the hypotenuse, equals to AB squared. AB is 5, therefore AB squared is 5 squared, that is 25. Plus BC squared. BC is 12, therefore BC squared is 12 squared, that is 144. In conclusion, further that AC squared equals to 25 plus 144. 25 plus 144 is 169. So AC squared equals to 169. Here we take a root out of this equation. And you get that AC equals to the square root of 169, that is 13. So the length of the hypotenuse AC is 13 units. So I write it down. AC equals to 13 units in its length. In the next step, we define the length of this line segment BG as X. So what is the length of line segment GC? From the drawing it is very easy to see that GC equals to BC minus BG again. BC minus BG equals to GC. So GC equals to BC, that is 12, minus GC, that is X. So in total, GC equals to 12 minus X. And we also define the length of one side of this square DEFG as L. So all the sides of this square DEFG will be equal to L because of the fact that all the sides of any square are equal to each other. we can implement in our drawing the rule that states that the sum of the angles on one side of a straight line is equal to 180 degrees. But again, the rule is that the sum of the angles on one side of a straight line is equal to 180 degrees. So we know that line segment AC is one side of the right triangle ABC. This is actually the hypotenuse of the right triangle ABC, and therefore it is absolutely a straight line. So AC is a straight line. So if we focus on the lower side of this straight line AC at point D here, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus the missing angle. In total, the sum of those two angles they must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees in its size. Again, in order to complete the sum of the angles in the lower side of AC at point D to 180 degrees, the missing angle must be equal to 90 degrees in its size. So this angle equals to 90 degrees. Likewise, we focus on the lower side of the straight line AC at point E. In the lower side of AC at point E, the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point E? We have this angle that is a right angle plus the missing angle. In total, the sum of those two angles they must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees. The next step, we define the size of this angle, that is actually angle ACB, as alpha, and we will focus on this, the big right triangle, triangle ABC. In the big right triangle, triangle ABC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees. That is the sum of the angles in any triangle. So the missing angle equals to 90 degrees minus alpha. We will define 90 degrees minus alpha as beta. So the missing angle here equals to beta. Here we have the equation that 90 degrees minus alpha equals to beta. If we add to this equation alpha and subtract beta simultaneously, we get that 90 degrees minus beta equals to alpha. In the next step, we focus on this right triangle, the right triangle ADF. In the right triangle ADF, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle equals to alpha. Likewise, we focus on the right triangle, triangle EGC. In the right triangle, triangle EGC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle must be equal to beta. Line segment BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if we focus on the upper side of the straight line BC at point G here, Here the sum of the angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of the straight line is equal to 180 degrees. So the sum of the angles on the upper side of the straight line AC at point G must be equal to 180 degrees. So which angles we have at the upper side of the straight line BC at point G? We have this angle that is beta, plus this angle that is a right angle, plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees. Therefore, the missing angle here must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles on the upper side of the straight line BC at point G. So the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle here equals to alpha. So, in the right triangle FBG, this right small triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle here must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle here must be equal to beta. In the drawing, we have in total 4 right triangles. 1, 2, 3, and the big right triangle, triangle ABC. Actually, all the 3 angles in all the 4 right triangles are correspondingly equal to each other. Each triangle has the 3 angles that are alpha, beta, and 90 degrees. And therefore, all the 4 right triangles are similar to each other according to angle, similarity rule. Repeat again because of the fact that all the 4 right triangles have correspondingly the same angles that are alpha, beta, and 90 degrees. Therefore, all the 4 right triangles are similar to each other according to angle, similarity rule. For example, the small right triangle FBG is similar to the big right triangle, triangle ABC. So I write it down. The big right triangle, triangle ABC is similar, this is the sign of similar, to the small right triangle, triangle FBG. According to angle, similarity rule. Both those 2 right triangles have the same angles, alpha, beta, and 90 degrees. Therefore, they are similar to each other according to angle, similarity rule. And from the fact that the right triangle ABC is similar to the small right triangle FBG, we derive that the following relationship exists between their sides. We will derive that BG over FG in the right small triangle FBG equals to BC over AC in the right big triangle, triangle ABC. Repeat again, from the fact that the right big triangle, triangle ABC similar to the right small triangle, triangle FBG, we will derive that BG over FG equals to BC over AC. BG is X over FG. FG is L. And it is equals to BC. BC is 12 over AC. AC is 13. In conclusion, found out that according to equation 1, X over L equals to 12 over 13. Here we multiply this equation 1 by L, and finally we get that X equals to 12L over 13. So according to equation 1, X equals to 12L over 13. We Note that the right triangle the right big triangle ABC is also similar to this right small triangle AGC. So write it down. The right big triangle ABC is similar, this is the sign of similar, to the right small triangle EGC according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we will derive that the following relationship exists between their sides. We will derive that GC over GE in the right triangle GEC is equals to AC over AB in the right big triangle ABC. Repeat again. From the fact that the right big triangle ABC is similar to the right small triangle EGC, we derive that GC over G equals to AC over AB. Okay, so here GC is 12 minus X over GE. GE is L. And it is equals to AC. AC is 13 over AB. AB is 5. So in conclusion, we found out that according to equation 2, 12 minus X over L equals to 12. Here AC is 13. AC is 13, so it is AC is 13 and AB is 5, so it is 13 over 5. We will cross multiply this equation 2, and finally we get that according to equation 2, 5 times 12 minus X equals to 13L. We'll open the brackets on this side of this equation 2, and finally we get that 5 times 12 is 60, and 5 times minus X is minus 5X. It is equals to 13L. Here we'll add 5X to this equation 2, and we'll get that according to this equation 2, 60 equals to 13L plus 5X. Here we'll subtract 13L from this equation 2, and we get that according to equation 2, 60 minus 13L equals to 5X. Okay, so according to equation 2, 60 minus 13L equals to 5X. So in the next step, we substitute X in this equation 2, but the value of X that we found in equation 1. According to this equation 1, X equals to 12L over 13. Therefore, we substitute X here by 12L over 13. We do it now, and we get that according to equation 2, 60 minus 13L equals to 5X. And X, according to equation 1, is 12L over 13. So according to equation 2, we actually found out that 60 minus 13L equals to 5 times 12L is 60L. So in total this expression equals to 60L over 13. Here we'll multiply this equation 2 by 13. And we get that according to this equation 2, 60 times 13 is 780. 13 times minus 13L is minus 169L, and it is equals to 60L. Here we add to this equation 269L, and we get that according to this equation 2, $780 equals to 60L plus 169L equals to 229L. In conclusion, found out that according to equation 2, 780 equals to 229L. Here we divide this equation 2 by 229, and we get that L equals to 780 over 229. 780 over 229 equals to 3.40611. So we found out that L equals to 3.40611 units. Actually, L is the length of this one side of this square DEFG. And we know that the area of any square equals to one side squared. So the area of square DEFG will be equal to the length of one side, that is L squared. That is to say, it is L squared. L equals to 3.40611, therefore L squared equals to 3.40611 square, and 3.40611 square is equal to 11.6016 square units. So in conclusion, we found out actually that the area of square DEFG is equal to 11.6016 square units. That is the answer to the question. I'll repeat again. The area of this square DEFG is equal to 11.6016 square units. So in the next step, I will summarize the lecture. In this lecture, we found out the area of this square DEFG. So in the drawing, we have a right triangle ABC. Inside this right triangle ABC, we have square DEFG, and our mission is to find out the area of this square DEFG. In addition, we know that the length of side AB of the right triangle ABC is 5 units. Side BC equals to 12 units in its length, and this is angle ABC, that is a right angle. So again, our mission is to find out the area of the square DEFG. So in the first step, we implemented the Pythagoras theorem on the right triangle ABC in order to find out the length of the hypotenuse AC. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse in the right triangle ABC is AC, therefore the square of the hypotenuse is AC square, so AC square must be equal to AB square plus BC square. Repeat again, in the right triangle ABC, AC square equals to AB square plus BC square. So AC square, that is the square of the hypotenuse, equals to AB square. AB is 5, therefore AB square is 5 square, that is 25, plus BC square. BC is 12, therefore BC square is 12 square, that is 144. In conclusion, we found out that AC squared equals to 25 plus 144. 25 plus 144 is 169. So AC squared equals to 169. We took root out of this equation and finally found out that AC equals to the square root of 169. That is 13. So the length of the opposite AC is 13 units. In the next step, I presented to you the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. We can implement the rule in our drawing. Because in our drawing we have line segment AC. Line segment AC is the hypotenuse of the right triangle ABC, therefore it is absolutely a straight line. So if you focus on the lower side of the straight line AC at point D, here the sum of the angles must be equal to 180 degrees. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees in its size. Likewise, if you focus on the lower side of the straight line AC at point D, here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned. So which angles we have at the lower side of AC at point D? We have this angle that is 90 degrees plus the missing angle. In total, the sum of those two angles must be equal to 180 degrees. Therefore, the missing angle must be equal to 90 degrees. In the next step, we defined the angle of this line segment BG as X. Therefore, GC will be equal to BC minus BG. Again, BC minus BG is GC. So GC equals to BC, that is 12, minus GC, that is X. So in total, GC equals to 12 minus X. Then we defined the length of one side of this curve DEFG as L, and therefore all the other three sides must be also equal to L because of the fact that all the sides of any square are equal to each other. Then we defined this angle ACB as alpha, and we focus on the right triangle ABC. In the right triangle ABC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. Why? Because 90 degrees minus alpha plus alpha is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees, that is the sum of the angles in any triangle. So the missing angle must be equal to 90 degrees minus alpha. But we defined 90 degrees minus alpha as beta, and therefore the missing angle here must be equal to beta. So here we have the equation that 90 degrees minus alpha equals to beta. If we add to this equation alpha and subtract beta simultaneously, we get that 90 degrees minus beta equals to alpha. Then we focus on this right triangle AFD. In the right triangle AFD, this angle equals to beta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, 90 degrees plus 90 degrees is equal to 180 degrees, that is the sum of the angles in any triangle. So the missing angle here must be equal to 90 degrees minus beta. But 90 degrees minus beta is alpha, therefore the missing angle equals to alpha. Likewise, we focus on the right triangle EGC. In the right triangle EGC, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle must be equal to beta. We know that line segment BC is one side of the right triangle ABC, therefore it is absolutely a straight line. So if you focus on the upper side of the straight line BC at point G here the sum of the angles must be equal to 180 degrees according to the rule that I mentioned, that the sum of the angles on one side of a straight line is equal to 180 degrees. So which angles we have at the upper side of BC at point G? We have this angle that is beta plus this angle that is 90 degrees plus the missing angle. In total, the sum of those three angles must be equal to 180 degrees. So the missing angle must be equal to 90 degrees minus beta. Why? Because 90 degrees minus beta plus beta is 90 degrees, and 90 degrees plus 90 degrees, it is equal to 180 degrees. That is the sum of the angles of the upper side of the straight line BC at point G. So the missing angle must be equal to 90 degrees minus beta. But 90 degrees minus beta equals to alpha, therefore the missing angle must be equal to alpha. In the right triangle FBG, this angle equals to alpha, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus alpha. But 90 degrees minus alpha equals to beta, therefore the missing angle must be equal to beta. So in the domain we have in total 4 right triangles. 1, 2, 3, and the big right triangle, triangle ABC. All those 4 right triangles have exactly the same 3 angles, alpha, beta, and 90 degrees. Therefore, all those 4 right triangles are similar to each other according to angle similarity rule. For example, the small right triangle FBG is similar to the big right triangle ABC. Repeat again. The big right triangle ABC is similar to the small right triangle FBG. And from the fact that the 2 right triangles are similar to each other, we derive that the following relationship exists between their sides. We will derive that BG over FG in the right small triangle FBG equals to BC over AC in the right big triangle ABC. I repeat again. We derive that BG over FG equals to BC over AC. BG is X, FG is L, BC is 12, and AC is 13. In conclusion, found out that according to equation 1, X over L equals to 12 over 13. Here we multiply this equation by L, and finally found out that X equals to 12 L over 13. Likewise, we know that the right big triangle ABC is similar to this small right triangle AGC according to angle similarity rule. Repeat again, the right big triangle ABC is similar to the right small triangle AGC. And therefore, the following relationship exists between their sides. GC over GE in the right small triangle GEC is equals to AC over AB in the right big triangle ABC. Repeat again. GC over GE equals to AC over AB. GC is 12 minus X, GE is L, AC is 13, and AB is 5. So in conclusion, we found out that according to equation 2, 12 minus X over L equals to 13 over 5. Here we cross multiply this equation 2, and finally found out that 5 times 12 minus X equals to 13L. Here we open the brackets on this side of this equation 2, and found out actually that 5 times 12 is 60, and 5 times minus X is minus 5X, and this is equals to 13L. Here we added 5x to this equation 2, and finally found out that 60 equals to 13L plus 5x. Here we subtracted 13L from this equation 2, and finally found out that 60 minus 13L equals to 5x. Repeat again, according to equation 2, we actually found out that 60 minus 13L equals to 5x. In the next step, we substitute this x in this equation 2 by the value of x that we found in equation for x in equation 1. According to equation 1, x equals to 12L over 13. Therefore, we substitute x in this equation 2 by 12L over 13. We did it and we got that 16 minus 13 L equals to 5x, and x is 12L over 13 according to equation 1. So in conclusion, we found out that 60 minus 13L equals to 5 times 12L is 60L over 13. In conclusion, we found out that 60 minus 14L equals to 60L over 13. Here we multiply this equation 2 by 13, and finally found out that 13 times 60 is 780, and 13 times minus 14L is minus 169L, and it is equal to 60L. Here we added 169L to this equation 2, and finally found out that 780 equals to 60L plus 169L is 229L. Here we divided this equation 2 by 229, and finally found out that L equals to 780 over 229. 780 over 229 is 3.40611 units. In conclusion, we found out that the length of one side of this square DEFG, that is L, is equal to 3.40611 units. And we know that the area of the square equals to the length of one side square. Therefore, the area of this square DEFG will be equal to L square. So again, the area of square DEFG equals to L square. L is 3.40611, Therefore, L square is 3.40611 squared. That is equal to 11.6016 square units. If we found out the area of this square DEFG is equal to 11.6016 square units. Okay, thank you very much.